Hi everyone, my name is Mohamed Youssef and I'm going to talk about disease prediction using machine learning. The steps on the agenda are as follows. First, I needed to understand the dataset I was working on. Then, I needed to import Python libraries which will significantly help with the task. Then, I did some EDA to analyze and investigate the data. Then, I needed to do some data pre-processing so the model can train well on the data. Then I trained three models: naive Bayes classifier, random forest classifier with random search hyperparameter tuning, and XGBoosting classifier with random search hyperparameter tuning. First, I needed to understand the dataset. The dataset is divided into two CSV files, one with 2000 plus rows for training and another one with 486 rows for testing. Both files contain 25 attributes. Despite the limited number of records and the presence of over 2000 duplicates in the training dataset, I was gonna do my best with the dataset provided. The target attribute disease contains 5 unique classes. If the patient has anemia, is he or she healthy? Diabetic, has thalassemia, or thrombocytopenia. Libraries used are as follows: time to get the number of seconds the model needed to train, NumPy for numerical computations, Matplotlib and Seaborn for plotting graphs and visualizations, Pandas for data manipulation and analysis, sklearn for machine learning models and tools, such as label encoder to encode the target variable, standard scaler to scale the values, confusion matrix to get the confusion matrix output, classification report to get the accuracy, precision, F1 score, random forest classifier to train the random forest classifier, Gaussian NB to train the naive Bayes model, randomized search CV to perform randomized search hyperparameter tuning, and XGB classifier. Then I did some EDA. First, I plotted the distribution of diseases in the training dataset. As we can see, the data is balanced except for the thrombotic disease. Then I did a plot of all the values of the attributes in the training dataset. As we can see, the mean is the dashed green line, the median is the dashed red line, and the mod is the dashed blue line. Then I did some pre-processing on the data. First, I encoded the target variables using sklearn's label encoder class. Then I split both the training and testing datasets to features and target variables: xtrain, ytrain, xtest, and ytest. Then I converted the features and target variables into NumPy arrays. Then I scaled the variables using sklearn's standard scaler class. Then I shuffled the arrays. First, I tried the naive Bayes classifier since it's fast, simple, and doesn't require that much training data. The model took less than 1 second to train, and it got a 93% accuracy on the training data and 58% accuracy on the testing data, showing a clear sign of overfitting. The reasons could be: the dataset size is small, the dataset is imbalanced, features are not independent since naive Bayes assumes that all the features are independent, and duplicate values. The dataset contains a lot of duplicate values which can lead to biased results. Here are the precision, recall, F1 score, and accuracy. Then I tried random forest classifier with random search hyperparameter tuning, since it's known to solve the overfitting problem. The model took 94 seconds to train and it got 100% accuracy on the training data and 45% accuracy on the testing data, also showing signs of overfitting. The same reasons apply: small dataset, imbalanced dataset, and lots of duplicate values. Here are the precision, recall, F1 score, and accuracy for the model. Finally, as a last result, I tried the XGBoost classifier also with random search hyperparameter tuning. The model also took 94 seconds to train and it got 100% accuracy on the training data and 41% accuracy on the testing data, also showing signs of overfitting. The same reasons apply: small dataset, imbalanced dataset, and duplicate values. Here are the precision, recall, F1 score, and accuracy for the XGBoost classifier. These are the final results. All the models had the overfitting problem, but the naive Bayes had the highest test accuracy and the lowest time. since it is based on probabilities and doesn't require a lot of training data, while the random forest classifier is based on bagging and the XG boost classifier is based on boosting. Thank you everyone for watching.